Good morning to our lecturer, Sir Chun Today, we will present about the presentation for practical task 1, Hooke's Law. We are from DKM 3B. Our code and course is DJJ 30093 Engineering Mechanics. Our program is Diploma of Mechanical Engineering. The presenter will be me, Cheong Ming, 20 DKM 20F 2010, ANAK Christopher, 20 DKM 20F 2021, FAIZAL bin ADHA, 20 DKM 20F 2030. And the last one is DENNILSON ANAK Jonathan, 20 DKM 20F 2004. First part that will be in our presentation is introduction. The second part is theory. The third part is procedure. And the last part is reference. We will begin our presentation with introduction first.
Introduction. Hooke's Law, law of density of electricity discovered by the English scientist Robert Hooke in 1660, which states that for relatively small deformations of an object, the displacement or size of the deformation is directly proportional to the deforming force or load.
Next, I will talk about the theory. Hooke's law statement. The restoring force acting on an object is proportional to the negative of the displacement deformation of the object in symbols. F equal to negative kx, where F is the restoring force provided by whatever is being stretched, squeezed. X is the displacement of the thing being stretched or squeezed. K is the constant of proportionality. The negative sign is important and just says that the restoring force is opposite in direction to the displacement.
My name is FAIZAL bin ADHA. I will present about this lab report 1. Next, we will move on to the next part, which is to the procedure to obtain the result of for Hooke's law. First, we need to click the link which in the lab sheet for practical task 1 that provided by our lecturer, Sir Chun. After clicking the link in the lab sheet, it will automatically open the link and surf into the internet or Google Chrome.
The head link will direct to us the app website. Go to the messages and spring topic and start downloading the simulation. After downloading, click on it to start the simulation. Then after the app open, adjust the spring bar to the smallest bar and the spring content to adjust it to the largest bar. Make sure also to adjust the gravity into Earth.
Before adjust the bar for spring constant 1 and 2, make sure that both spring head selected as compare spring constant. The next step is we can hang on the load to the spring 1 and 2. Firstly, start with the load of 50 gram. Hang the load to the spring constant 1 and tick the box for natural length and equilibrium position on the right screen. This is to make the natural line and equilibrium position line appear so that we can measure the elongation of the spring using the ruler in the simulation.
After that, drag the ruler to the line for natural length. The top of the ruler must be parallel to the line and cover it. Next step is measure the length from point of natural length to the length of equilibrium position. Record the observation and repeat it with load 100 gram, 250 gram for spring. After that, repeat the experiment for the spring constant 2 with the with same procedure for spring constant for with load of 50 gram, 100 gram and 250 gram. Measure those lengths and record it as a result.
This is the picture for the graph of spring constant 1. And the next one is the graph for spring constant 2. Sorry for the interruption, but there is a mistake in the slide. The spring constant 1 should be spring constant 2.
The slide had stated that this is for individual progress. We find our reference from website which is Google. There are two links that stated in the slide which we find the information from there. That's all for us. Thank you.